Yeah, so the format for this particular chat's going to be kind of a fireside chat where Tim and I go back and forth, ask some questions, and then we'll make sure to make time for Q&A session at the end. But I wanted to kick it off. Tim, do you want to give a little bit of an intro of yourself
Sure.
and ZincFive, and then we can get into it?
Yeah, absolutely. So, CEO, co-founder of ZincFive. As I said in the intro a few minutes ago, we are the manufacturer of a battery chemistry called nickel zinc. We're a bit unique in that we're the largest provider, commercial provider of nickel zinc batteries in the world. But also, what we do that's kind of, well, not kind of, it's very different, is we actually take our batteries and we build out commercial products with them. So I'm sure today we'll talk a lot about data centers, a lot about AI, but just how, industries now try to choose the best chemistry for the best job or for a particular task. Gosh, I think probably 5 years ago, everybody thought lithium would solve everything. And lithium is good for a lot of reasons for certain use cases, but not for others. And so we'll talk a lot about, mission critical applications, shorter duration, not longer duration applications with battery choices. And, literally, how do you go from an idea to all the way to having commercial success to deploying product? For instance, I'll give you an example. We have now deployed in the data center industry over 1.5 gigawatts of our battery backup cabinets using our nickel zinc batteries. So we'll, I'm sure, talk more about that. But to gain some insight and share some insight with all of you about how hard this is. Battery technologies are incredibly hard, and to get them to a point where you're profitable and you're growing commercially is a long, long journey. And so we can talk about some of that if you like as well. But yeah, that's our story and a backdrop. Crystal?
Yeah, thank you for that. So you already touched upon some of these things, but I did want to ask. So, ZincFive works on nickel zinc batteries. What are the specific applications where nickel zinc batteries shine?
Yeah, so just playing off of some of the things I said a minute ago, when you take a look, a lot of folks always ask us the first couple questions about our technology. The most common question is, what's your cost per kilowatt hour? Okay, that's a very common question. And actually, when we get asked that, I kind of smile and chuckle because we don't play in the kilowatt hour space. We play in the kilowatt space. So we deliver all of our power. Think of it this way. We deliver it in minutes, seconds, milliseconds, or even nanoseconds. And some of those areas we'll, I'm sure, talk about relative to AI, in terms of what power is needed for computing the AI GPU chips. But the other question we always get asked is cycle life, right? And it's like, okay, well, cycle life's important, but you have to understand what commercial industry you're trying to penetrate. So, for example, in data centers, they're not looking for thousands of cycles. They're looking at probably 10 use cases a year where utility power is disrupted and they need our technology to power the data center for just the servers, by the way, and cooling, but 3 to 5 minutes. And if you're unfamiliar with data centers, that's just enough time for the on-site generators to power up and take over. So then once power is restored, we come offline and we start to recharge off of the primary power source that feeds the data center. But AI is completely different. So anyway, the point I'm making is in data centers, they're typically looking for a useful life of 15 years. So that's 150 cycles, not hundreds and hundreds or thousands. Now, AI is totally different. They're looking for millions of cycles, which we can talk about. But anyway, the kilowatt hour question is always a curious one, until you understand that there's a chemistry like we have that really focuses on this high power application space for very short duration. Again, minutes, seconds, milliseconds, and nanoseconds.
Yeah, so that's really good insight here. So you've mentioned a couple things that are not super critical for you, cycle life being one of them, dollar per kilowatt hour. What are the primary performance metrics that you do care about when you were starting ZincFive?
Yeah, well, safety was number one for us. We wanted to utilize and scale a battery chemistry that didn't have the risk of fire, thermal runaway, and explosion, especially in these mission critical applications that we're pursuing. The last thing a data center operator wants is a massive fire in their data center. It's catastrophic, especially with certain types of chemistries. So we overcome that. But really the other thing that is important, because of our very high discharge rates, what are called C rates, we're able to have the smallest footprint in this industry. So when we talk about megawatt class battery backup cabinets for data centers, we take the smallest amount of space. On top of that, and that's all players, lithium, lead acid batteries, it doesn't matter. We're significantly smaller. And space is a very expensive piece of the data center build out. So the other thing, because we're safe, we don't have to have the same level of fire suppression that, say, other chemistries need, which is also a cost savings to the data center. So it's footprint, it's safety. And then the last thing is probably worth pointing out to this group is these data centers are trying to be as much as they can be environmentally conscious, or on the sustainability side. Well, our batteries are over 90% recyclable, and there's value in the recycling process because we use nickel, byproducts of nickel, copper, and zinc. So it's much more cost effective in our world to recycle our batteries for battery grade material than to keep mining, right? That's another major difference. So yeah, that's some answers to your question. Those are the value props, and that's why we're having such great success in the data center industry.
Yeah, that makes sense. Could you tell me a little bit about the history of, how you found nickel zinc in the beginning, and what kind of use case or application really spurred the growth
Yeah.
of the company?
Yeah, it's going to sound contradictory because of everything I just said, but the very first product that we ever built with nickel zinc batteries before we owned the chemistry was, believe it or not, battery backup for stoplights, right? So when utility power is disrupted at a stoplight, a lot of people think that the stoplights flash red, right? Well, they don't. They actually go black, and there's horrific accidents all the time when utility power goes out at a stoplight. Well, the reason I'm telling you this story is we launched that product back in 2012. It was our very first full-scale UPS product. But here's what's interesting is that use case isn't minutes, seconds, milliseconds, and so on. That particular use case, we back up those intersections for 2 to 4 hours, right? So our chemistry is capable of longer duration. And you might be curious, well, why don't you try to go compete in longer duration applications? Well, truthfully, lithium has much better energy density than we have. They don't have the power density we have, but they have better energy density. So what that means is economically, if municipalities or cities felt comfortable with the safety issues with lithium, they would probably do very well there, but that's not the case. They're very sensitive to safety, and because the battery backup set literally out of the street corner. But back to your question, Crystal, that was the first product that we ever launched. Now, we learned a lot about our chemistry and the BMS we had to create, battery management software and form factors, et cetera. And so those things that we learned is that our nickel zinc batteries are really exceptional and very difficult to beat commercially when you get into those shorter durations versus longer durations.
Yeah, definitely. Do you mind expounding a little bit on, so what you're really talking about here is product market fit. Like you
That's
found a
right.
particular application. Um, what were some of the key challenges in kind of proving out for this stoplight example, let's say, and
Yeah.
proving out that nickel zinc chemistry could suit that application? You talked a little bit about BMS, but what else kind of came up?
Yeah, well, probably the best one to talk about is, because it's a much larger market and might lead us into AI. But the battery backup for data centers, the barrier of entry is massive, and it's not just cost but time. So we knew we had an exceptional battery. I'll give you an example. We knew we had an exceptional battery for the shorter duration, which fit the needs of the data centers, right? But you can't just, and a lot of you on this call will know exactly what I'm talking about. You can't just take an amazing battery chemistry and go to an industry and say, boy, try this, it's going to be great. Right? It just doesn't work that way. So we literally had to do some major things. Number one, we built our own battery backup cabinet with our own BMS, et cetera. And what we did, because we have to have these battery cabinets coupled with OEMs inverters to build the full scale solution for data centers. So when I say OEMs, I'm talking about Vertiv, Schneider, ABB, Eaton. Mitsubishi, and so on and so forth. So we did something quite clever. Not only did we build these battery cabinets that they wouldn't do, but we also built a BMS that made it retrofittable and configurable with all of their inverters, right? So you had to overcome that. Now, even with doing that, it still takes years to get those folks to approve your solution, which they've done now with us, the majority of them. So that's the barrier of entry, not just having a chemistry, but literally having to design products is another 5+ years plus a lot of money, to be truthful, before you can ever penetrate those particular spaces. And now, once you're here, I say this on occasion, tongue in cheek a little bit, but it's true, is in this industry that we all live in on this call, no one sneaks up on you, right? Because of the barrier of entry it is to get into the commercial side of all of this and be profitable too, have profit in your product is also always a challenge. But yeah, hope that gave you some insight there.
No, that was very interesting. Yeah, it's interesting to hear about the evolution here. How do you see nickel zinc in particular evolving over the next decade, let's say? You've hinted a little bit at AI, kind of
Yeah.
where are the use case and applications there?
Yeah, so anything that you all can think of that is, most of the world's never known of a battery chemistry that does what we do in this short duration, high power, and being safe, and so on and so forth. And also handling ambient temperatures quite well, for example. But all of you should just think about, any use cases where a short duration, again, less than, minutes and seconds and so on. But in the world of AI, in fact, we just took our first order for the first one in the world battery backup cabinet that can also solve for the AI high power pulsing. If those that know how a data center works that computes AI, if you're not aware of this, every second there's 50 millisecond bursts of power when the GPUs are computing, the GPU clusters are computing, that typically are 20 to 40% higher than what the traditional data center grid power needs to support. So it's a real problem to the scaling of AI. And so we've been working for a little over a year now on handling those spikes, right? Now let's talk about cycle life. You're not talking about 150 cycles for that particular use case. You're literally talking millions of cycles, okay? And we've already proven with the leaders in this industry that our batteries can tolerate those spikes, and they can do it in a number. I'm not going to disclose the number, but I will tell you they've confirmed with us that we have a useful life of probably 5 years for that particular type of use case. And again, we're small, we're safe, nice sustainability story, which is very difficult for any other chemistry.
Yeah, that makes a lot of sense. For a lot of people on this call and a lot of folks in the battery space, like they might be a lot more familiar with, LFP or even lead acid batteries. And you kind of hinted at this earlier that the economics is fundamentally different. But I do want to zone in on that question. Like,
Sure.
let's say, LFP drives down the cost dramatically
Yeah,
over the years, $1 per kilowatt hour.
sure.
What would make nickel zinc a better fit than LFP or let's say lead acid batteries for a backup solution?
Yeah, well, that's who we compete against now, right? And that's who we win against literally every week nowadays. And the reasons are for some of the reasons I said earlier is number one, data centers do look at 10-year cost of ownership, number one. And so even if you're not the cheapest at the day one price, you are over 10 years. And those things that are calculated into that TCO is your replacement costs, maintenance costs on batteries, your fire suppression, let's not forget footprint, right? Footprint's huge, and more of these UPSs are being built now off-site to accelerate data center build outs in what's called a container or a modularized container. Well, every linear foot that we save compared to another chemistry in those modular devices is worth $10,000 per linear foot. So it's meaningful when you look at the footprint we have compared to the other chemistries. But really, predominantly, Crystal, in today's world, because the computing power that's happening with data centers and climbing every day now, lead acid doesn't really come into play much anymore, especially for a new build data center. It's really between us and, generally speaking, Samsung and a lithium solution. And those are the reasons we're winning, is because of footprint, safety, maintenance, fire suppression, all the other associated costs.
Yeah, that makes sense. I want to ask maybe one or two more questions before we turn it over to the audience and have folks be
Sure.
able to ask. Um, yeah, I guess having led ZincFive through the evolution, what lessons have you learned? Like, what were the biggest challenges in scaling?
Yeah. Well, the, the reason I said earlier no one ever sneaks up on you is because we all on this call hear about a new novel chemistry that's a coin battery in a academic lab somewhere or being tested. Well, I can tell you from personal experience, to go from there to scaling your manufacturing of your batteries into different form factors, larger and smaller batteries, and then not only taking that scale of the manufacturing, but then going and creating products, that is a long time and a lot of money, to say the least. So, just the scaling of the manufacture is where most battery technologies fail, right? Because it's not hard to make a coin battery, but it's really hard to do high volume, consistent manufacturing in a cost-effective way, and being able to replicate that in other parts of the world if you need to as you grow. But then again, coming up with the innovation around products that you use your batteries for, and having it be a market fit for a particular industry, and having the confidence that you can compete, right? Just because you have a better chemistry doesn't mean you're going to win. Every industry is still going to be cost conscious, and so it's all of these things. So I say a lot in my organization, just because we can doesn't mean we should, right? Because we get a lot of industries coming at us asking if we would consider using our high power battery for a particular use case. And if they say, or we determine that that's going to be like a 5-year window before we would commercialize something, we're going to pass. There's just too many industries right now that need high power solutions, short duration, where you can turn it into commercialized profitable revenue within 12 months in many cases. So those are all lessons learned. Really be thoughtful if you're about how hard it is and what it's going to cost you. It's going to be probably 2 to 3 times more expensive than you thought, and at least a few extra years longer than you might have imagined.
With 5 minutes left to the official end, I want to open it up to the audience to ask any questions from Tim that they would like.
Hi, Tim. Great to hear from you. My name is Trenton Gallagher. I'm from Cool Technology. I'm actually an Oregon native, so I know a lot about your company.
Oh yeah,
I've followed it for
cool.
years. Actually, I received my PhD at Oregon State University,
Oh,
and
fantastic.
under David G. And I've heard a lot about your company and had a few colleagues of mine do internships and things there. And great to see your success. I'm happy to be here today and hear you talk about your company. You touch a lot on kind of some challenges that we're going through right now at our company, and that is getting from the coin cell to pouch cell, prismatic cell, going up to the module level. At the coin cell level, everything seems to work just fine, right?
Yeah, that's right.
And that's always the case. It always
Yeah.
seems to be the case. And then scaling up kind of to the pouch cell. I mean, we're at the pouch cell level now,
Yeah.
to give you reference on that. I mean, what kind of things did you implement at that level to find success? I'm really looking for, at that smaller level, jumping to the next section. What kind of things did you do?
So I don't think it's too early, Trenton, to, if you know what your chemistry is really good at.
Yeah.
It's not too early, even at this stage, to start to identify that commercial market that you're going to be able to sell into, right? And starting to profile, price points, competitive landscape, distribution, who else competes there? What could displace you if you did get there and maybe something else comes out that's as good or better. But as you're doing the battery scaling, be doing that at the same time, right? because if you're not, what you're at risk of doing is going from a coin to a pouch, and just, I guess I would, at some point you got to draw a line. The chemistry is as good as it's going to need to be right now. We can make it better downstream, but we have something that we can use commercially. So that would be the first thing I would tell you. The second thing I would say to you is, every solution probably, depending on what market you would go after, would probably string a number of these batteries together. For instance, in our battery backup cabinet, we have 38 batteries that are effectively the size of a car battery, nickel zinc batteries, right? So as soon as you can, start to string batteries together and see how they behave, because there's balancing issues. There's all sorts of issues that come when you go from a single cell testing to strings of batteries. So anyway, those are just, a few front end comments I would share with you is, really start to feel comfortable. You got a real commercial market waiting for you as you do, the expansion of your chemistry.
Wonderful. Thank you.
You're welcome.
Yeah.
My pleasure. I want all battery chemistries to win, because the industry's massive, right? It's just massive. And, this is part of the theme of this topic today is, what best chemistry is for what best use case. And as I said earlier, 5 short years ago, every call I was on, the listener thought lithium was going to solve everything. Well, chemistries just don't work that way, as most of you on this call know. You either are good at one thing and not so good at another, or vice versa. And some industries just absolutely demand safety. Some demand space. Some demand all that. So yeah. Anyway, hope that helps, Trent.
Absolutely. Yeah. Thank you so much for your time.
Yeah.
Yeah, Tim, thanks for speaking. My name's Josh Hitt. I have a question. I have a startup at the Pacific Northwest as well, working on some similar areas. But I guess I have a question. So you sell modules into applications, but you also sell the cells. How do you, does that ever create conflicts for you? And how do you address those with your customers?
Yeah, so we're a little different than that, Josh, because what we do is we do manufacture our nickel zinc batteries from the raws. And then in certain instances, we put them into packs or strings, right?
Mm-hmm.
And then those batteries ship in here to the US. And then here in the US, the product we're having the success with right now, the battery backup cabinets, we do the assembly of the cabinets here right down the street from us in Oregon. So that's how it works. We don't typically just sell the batteries to any industry, with the one exception. There's two actually. Our nickel zinc batteries have exceptional cranking capacity, think motors.
Mm-hmm.
So one of the other products that we have is one that's an industrial starting battery for these large generators, multi-megawatt generators that set on site at data centers. So we have a distribution partner that builds that product. We just give them the batteries to put inside there.
Got it. Got it.
The traffic product that you heard me talk about earlier with Crystal for backing up stoplights, that's different as well, because we launched that entire industry on our own. And then about 1.5 years ago, we ended up licensing it off to one of the major players in that space. So now they manufacture that whole product for us. All we do, Josh, is just provide the cells, right?
Yep.
And we get royalties and all that good stuff. So, but yeah, your question really highlights what I've been talking about too, is it all depends on what market you're going after and what you're trying to how you're trying to win, right? Competitively. Are you going to win with just cells? Are you going to win with packs? Or are you going to win with products, full scale products? And that's a question for every market you might want to pursue.
Got it. Thank you. Appreciate it.
You're welcome.
I have a question. Thanks, Tim, so much for the talk. This was really interesting. So going off a little bit on the last question that Josh had, when you are selling your battery systems to, for example, the data centers and handing them off there,
Yeah.
Are you managing the maintenance of the batteries and all of the operations of the batteries during that time also, or handing it off? And if so, can you explain any challenges with that process or observing what you need to do for the maintenance? Thanks.
Sure. Yeah, absolutely. So within the data center space, the real buyers of our product are not the end user data centers typically. Typically, it's the likes of Schneider, ABB, Vertiv, and so on. So, and the reason is because they're coupling their inverters with our battery backup cabinets, and then they're providing that holistic solution to a particular data center that's asked for ZincFive, right? So that's how it works. And so with that model, it's great for us because I don't have to build out a sales and service organization the size of Schneider's or Vertiv's, right? So you get to take it, once you're under master purchase agreement with them, which we are, they basically use their own sales and service support teams to install their inverter in our battery backup cabinets, and then also provide the maintenance as the years go on. Now, our batteries require very little maintenance. And so, you know, we have a 10-year warranty on our batteries, which is unheard of. But that's because, you know, they sit there and most of the time do nothing, right? Which is interesting. But yeah, that's how the sales and support organizations work. It's through the likes of the major OEMs. And it's a benefit to us. And the data centers, you know, these are massive data centers, right? So they really want to, you know, have that direct relationship with the Vertivs and the Schneiders and so on.
Got it. Thanks. One follow-up. So the 10-year warranty is something that I think a lot of other companies have, which is definitely very impressive. My question is, do the batteries usually last about 10 years or 5 years, and there's in the master service agreement, there's like a replacement built in there? Could you explain how that works?
Yeah, so the batteries actually are 10 years. I think lithium is sort of a more graduated approach. Ours is 10 years. And the reason is we don't have sulfation and things like you see with called lead acid batteries, right? We just don't. And so really what the industry asks you for is, say, for example, they want 3 to 5 minutes at the beginning of life, right? So at initial install. Well, you have to show the testing through ABB, Vertiv, Schneider, and all these guys that you can also meet what's called end of life runtime, right? And so that's typically somewhere between 3 to 5 minutes. So that's all they really care about. So it really isn't necessarily cycle life, as I said earlier, because you're not hitting the batteries all that frequently. It's really just, does your batteries behave and how do they behave over that 10-year period? And ours is just, you know, it's pretty benign use case for us.
Got it. Thank you.
Mm-hmm. Good question.
Are there any last breaking questions? I want to be respectful of Tim's time here, so we're at time. But thank you so much for all of your questions and Tim for providing that insight over the years.
My pleasure. It's scar tissue I like to share. So maybe people will find it of value and not have the same scar tissue. So yeah.
Well, thank you so much and hope you have a great rest of your day.
Great. Thanks everyone. Appreciate your attendance.
Thank you.